AO2.11 protocol. About the AO2.11, we have lots of type, right? We have AO2.11G, AO2.11A, B, and AO2.11N, and like the Wi-Fi 5, like the Wi-Fi 6. And here, this topic, we will discuss some key technology. Why the speed, why the bandwidth of Wi-Fi 5 is higher than AO2.11n, and why the Wi-Fi 6 is higher than Wi-Fi 5. And in this process, we will have lots of concepts we talk at the beginning, right? We talk about the beginning. And later, let's say, we have two bandwidths we can use. One is 2.4 gigabit and another one for 5.8 gigabit. And this point is used for ISM, it's industry, scientific, and medical. And about the AO2.11, we have lots of different protocols. AO2 the A, B, G, N, AC, and AX. AC is Wi-Fi 5 and AX is Wi-Fi 6. And the different protocol can be used for different band. This is the first one we have to know. Like the AO2.11a only can be used on 5G, but about AO2.11n and the Wi-Fi 6, both two brand we can use. And different band we can use different channel. And also finally we will get different speed. About the 5 gigabit, we have 13 channel, but about 2.4 gigabit, we only have three channel. But this three channel means we can use three channel at the same time in one devices, and there are no influence with each other because the channel is not overlapping. And another one is a modulation technology. This also is the reason why Wi-Fi 5 or Wi-Fi 6 the speed is higher than the others. And the data transmission rate, and about the Wi-Fi 6, the upper to 10 gigabit. Of course, this is a theoretical speed. And if there are no other influence, maybe we can get the 10 gigabit. And here is a release time. And first, let's say 2.4 gigabit. And about the 2.4 gigabit is the range is from 2.4 gigabit to 2.4835 gigabit. And here totally 14 channels can be divided in this frequency range. And about each channel, what's the start channel, what's the end channel is here. Like the channel 1, the start is 2.402 gigabit. And the bandwidth is 20 hertz. So 1, 2, 3, 4, 5. These five channels, there some message are overlapping. So if you use a 2.4 gigabit in your network, you can use the channel 1, channel 6, channel 11 at the same time because there is no overlap. Okay, so these are 2.4 gigabit. And another one for 5.8 gigabit channel. And this channel space also is 20 mHz. And this is the channel width. And 10 mHz to the center frequency on the left and right. And the total channel of the China bandwidth, we have from 36 to 64, and also from the 148 to 165. Maybe different country a little different. There is a little different. So therefore, about 5.8 gigabit, there are totally 13 non-overlapping channels. That's why someone say if we use a 5.8 gigabit, we can have higher bandwidth than 2.8. This channel likes the road that maybe your car can pass through. If you have more channels, maybe lots of car can go by. Okay, so this is 5.8. And then before we talk about the Wi-Fi 5 and Wi-Fi 6, let's see some key points of the AO2.11. because AO to the 11n, because 5 and 6 is improve the speed based on this technology. About the AO211N, we have lots of technologies like OFDM, FEC, MIMO, short GI, 40 MHz. So first, let's see about the AO211A and G. And these protocols, of course, maybe I guess lots of places not use these protocols. And the time of transmission is fixed to 4 hours. And this technology uses 64 quadrature amplitude modulation. This is a technology of QAM, encoding mode. You only remember the name is enough. And every subscribing channel, we will carry 6 bits of the date in the transmission. The OFDM technology adopted by AO2 the 11G can provide 52 subscribe channel, but in the 52 subscribe channel, only 48 are used for data transmission. Wireless is a little different with the wired cable, because about the wireless, you don't know on your side there is the other one sends a message or not. So you need some resources to send out to do the detect. You can think this message belongs to the control message. So, like the sub carriers, we have 6 carriers to send out the to carry the control message to detect the conflict or not. So if we use this technology and provide the 4 bits rate every time, therefore, the maximal rate of AO2 the 11A and G finally will become 54 Mbps. This is the biggest range, but in the real time, the rate is smaller because you also maybe need some message to do detect. And also maybe you some signal will pass through the wall, pass through the door, the signal will be reduced. Okay. And about the AO2 11A and G, we have totally 52 subscribe available, and 48 is the date subscribe, and about the 4 are pilot time subscribe. These 4 are used to do the detect. So the maximal rate will become 54. But about the AO211N, totally we have 56 subscribe available, and 52 is a date subscribe, and 4 is used to detect. So increase the subscribe, we can make the rate bigger to become 58.5. Of course, you don't need to know why we increase 4, why we don't increase to become 80 or the other value. It doesn't matter. This protocol is designed by this organization like the IEEE. We have to do is only buy the devices, and the devices can support AO211N. And then when you do the configuration, when you add the command or maybe use the GUI page to finish the configuration, you have to select the protocol to become AO211N. It's enough. And finally, when we do the message transmission, they will automatically to choose 52 as a data subscribe. And in this process, I only show you what's the detailed technology on these protocols. Not means you have to add the configuration. It doesn't need. You only choose this protocol. Then this protocol will automatically have 56 subscribe. And another technology for FEC, forwarding error correction bit of AO211A and G is 334, right? But the FEC bit of the 11N is 56. So the rate also can be improved 11.11%. So the speed will become 65 Mbps. And another one for the short GI, The GI is used for the OFM because between two signals we need some resources to stop us transfer the message. We cannot send the message all the time. Maybe there is a conflict. And in the AO211A and G, the GI time is 800 ns. But about the AO211N, we use a short GI. The short GI is reduced to become 400 ns. So finally, the speed will become 72.2 Mbps. Of course, someone maybe say why we directed to make the time to become 100 ns to improve the speed better. If the time is too short, like these two signals, there is a conflict, right? If the time is too long, here we will have empty resources, and this is a waste. So in AO2N, we use the time is 400 ns. And the next technology is channel bonding. And in the AO211N, we use the channel bonding 40 MHz. For example, about the 5.8 gigabit, each channel we have 20 MHz. And in avoid the overlapping, we will choose some channels that the coverage is not overlap. And within these two channels, there are also some resources cannot be used. So if we use a bonding, we can make the channel bigger and to make the speed higher. So if we bond the 40 MHz and with 100 M subscribe, and finally the speed will become 150 from 72.2 to become 150. And of course, when you do the configuration, this part you have to select. You have to select you use the channel bands to become 20 or 40. If you use 40, finally you can make the speed bigger. And the next one for the MIMO. MIMO means like this message. I have to send the message 1, 2, 3, 4, 7, 8. And if you have 3 antennas, and these 3 antennas, all of them can be transfer out the message at the same time. One antenna, 1, 2, 3, 4, 5, 6, and 7, 8, 9 at the same time. Then the message will be sent out within 1 second. Otherwise, maybe these 8, 9 values will be transferred in 3 seconds. But now you only need 1 second and three input and output. Then 1 second you can send all the message out. So this is a memo. And pay attention about this technology. You have to let your AP support multiple input, support multiple output, and your client also have to support this feature of MIMO to receive this message at the same time. Otherwise, if your client also only can support one, your AP can send out many messages at the same time, but your client cannot deal with it. So this is the tension. Also, the same reason someone say, why my AP already supports the Wi-Fi 6, but finally I use my laptop or my phone to do the test. The speed is not faster. That's because your client also have to support this feature. Okay. So if we use a MIMO technology, the speed can become 600 Mbps. And how many multiply speed you can get depends on how many streams you can use. And on the Ruijie devices, the special stream up to 4. Okay, up to 4. And finally, the client can get the 1 to 9 at the same time. This is a MIMO technology. Of course, it depends on your real devices. Maybe some devices cannot support. So you have to check the parameters when you buy the device. And this MIMO likes the channel of this picture. On the upper and the down, lots of car can send out, can go through at the same time because they use different space. Okay, use different space. So about AO2 the 11N, finally, according to the OFDM technology, FEC short GI 40 MHz band and the MIMO technology, the speed will up to 600 Mbps. And we also can use 20 MHz or 40 MHz. And about the GI time, we can select 8 Ms and 400 Ns. Pay attention about the GI, the time. If you select shorter, maybe you will increase the possible that there is a conflict because the time is too short. If you choose 8 ns, 800 ns, maybe when you send out the message, later you can send the second message. If the message is a conflict, we have to send the message again. So pay attention about this part. In your network, if you have deployed lots of AP in one places, and you also make the time shorter, maybe will increase the possible to let the devices conflict, to let the message conflict. If the message conflict, we will let the devices to send the message again. So pay attention about this part. And the next part, we will discuss something about the AL211AC. And this part, maybe let's have a let's have a break and come back 15 minutes later. We will continue to talk about the Wi-Fi 5 and Wi-Fi 6 and the next part of the FAT AP. About this technology, it doesn't matter. When we discuss the detail, I will tell you which technology. Maybe when you do the configuration, you have to select the special one. If the technology like the QAM, this is done by the protocol automatically. You cannot change the QAM detail. You only can directly use it. So it doesn't matter. No need to remember all the technology detail. Okay. We now know some basic technology, basic speed of the AO2 the 11N, right? Now let's see the Wi-Fi 5 and the Wi-Fi 6. About the Wi-Fi 5, at the beginning, we will have to know that we have two waves, wave 1 and wave 2. And wave 1 and wave 2, you can think this is different time, and we create for the AO2 the 11AC. And the speed also is different. And first, let's see about the AO211 AC Wi-Fi 5 Wave 1. We use some technology of 80 MHz channel bonding. So, okay, so this product I will check later about the speed. And about the AO2 Wave 1 80 MHz channel bonding. On the 11N, we only use 40 channel bonding, right? And about the QAM also is different. We use 256. And we also use a MIMO technology, multiple input and multiple output. And about the wave 2, the speed is higher than wave 1. We use the technology of MIMO. The first MIMO is single user. The MUMO is multiple user. So not only about the AP, we can send out we have multiple antennas and we can send out the message at the same time and also can receive the message. And in the wave 2, we also can support the client to receive multiple resources. And about the bonding technology, we can support 160 bonding and 80 plus 80 MHz bonding. So let's see the detail one by one. About the wave 1, we use the channel bonding technology of 80 bonding. 80 bonding like this one. At the first now L211N, we already have the speed is 150 MHz. And now we can use 80 bonding, so the speed will become 3025. And the 150 MHz is a rate at the 40 Hz in the L211N, right? At the first, we already know it. So if we have multiple bonding, we also can create the speed and faster. Lots of empty channels still can be used. Okay. And another technology for the QA, we can use 256 technology. So on the L211N, we use 64, but now we can use 256. That means in the same space, we can carry more resources. Okay, we can carry more resources. That's like on the L211N, we only can carry 6 people on the car, but now in one car, in the sub-square, we can carry 8 people. So you can see this indicator, you can see the note. Okay, you will get the point, and lots of resources can be added on the wave. So according to this technology, the speed can be increased 30%. Now the speed can become 433.33. So this is a technology. And another one for the MIMO. And on the wave 1, now we can up to 3 MIMOs can be used at present. And wave 1 can support up to 300. You can think if on the wave 1, one terminal, one the MIMO, one the antennas, we can use 433. 3 means you can use 3 channels at the same time, and all them can use the same technologies, 80 MHz band, 80 MHz bonding, and can use 256 QAM together. And you can think these are 3 rules we can use. So this is a wave 1. The upper speed is 1300 Mbps. So this is the technology. If we use one stream, only 433, and the 2 is 868. About the 3 streams used together, we can use 1 gigabit 1.3 gigabit hertz. And the wave 1, pay attention, the upper speed is 1.3 gigabit, but different scenario we use the speed is different. For example, if one link now we can support 3 MHz, this only is an example. About the wave 1, if we have MIMO devices, there's a AP can support multiple input, multiple output. But pay attention, if your station only is a single station, only one station here, but not support the if the station can support MIMO suggestions, that means example one link is 300 MHz can be forwarded out. So in this scenario, maybe one station, the through output is 900. And another one, if we have one AP support multiple MIMO support MIMO technology, and we have multiple stations on the AP together, and all of them can support MIMO technology. 2 and 3. Because we have the time limitation, I can send the message on station 1, and later I will send the message to stage 2, and later I will send the message to stage 3. This based on the time to transfer the message. In this scenario, each station will get 3 through output. 300 through output, because we cannot send all the message with 3 stations together. We only have 3 antennas. And another one, if we have the MISO, multiple input but a single output, and we only have single station, in this scenario, we only can support one message at the same time. So as the result, the station only can get 300 MHz resources, the through output. If in the same scenario of MISO, the single output, also maybe you have the multiple station, but the upper through output is 300. So as the result, I will send the message to switch 1, and then send the message to switch 2, and then send the message to station 3. So finally, each of them gets the throughput is 100. Is 100. So if we have the single user MIMO technology, we own under the that means one AP, one station. We have the limit. All the resources can be sent out for the station, only one. And the SU means we only have one station, and we don't have the MIMO technology of the AP. And the third scenario is we have lots of stations, and this user also can support the MIMO technology, and the AP also can support the MIMO technology. This is the best scenario in our network. So this is the first one. All the resources can support 2 stations because the AP also can support the MIMO technology. The next part, the second scenario, the AP only can support one single input, single output. And third one, the MIMO technology, you can think I can send the message to 3 stations at the same time. But pay attention, I will send the message to station 1 at the beginning times. Later, I will send to station 2, and then I will send to station 3. So based on the time. And about the wave 2, we can use the MU-MIMO, multiple user and multiple input and multiple output at the same time. So about the beginning, if the wave 1, we maybe only have one channel and a single user, but the MIMO technologies. About the wave 2, we have the channel assessment user group and the pre-coding and the beamforming technology to support multi-user, and the AP also can support MIMO technology. So in these scenarios, the wave 2 also can increase the speed. The channel assessment means about the L211AC supports the NDP technology. And about the NDP function is AP will send an NDP message to the station. Then the station will receive the compressed beamforming matrix to the AP. So the AP can obtain the current channel information, and then I can make a special channel for the user. This is a purpose why we need the NDP, because the AP want to get the current channel information from the station. And then we can divide different user into different user group. Each station will send the metric message to the AP according to the current channel information. And based on this information, the group AP will group the station by the MU-MIMO pre-coding conditions like this topology. We have blue one and orange one, and they were located into different group. Then we can send the message at the same time, and to increase the speed to send out more resources. And the pre-coding and beamforming information is, this is a little difficult, complex technology according to different phase. Because now about the AP, we have 3 MIMO, right? Multiple input, multiple output, and different terminals already located in different group user. Then we will integrate different phase. And for example, about the first one, I will adjust a phase. And about this phase, I will increase the signal of the laptop. But I will reduce the signal of the rest of the group. Then I can let the first laptop has more resources to transfer the message. So in this scenario, we finally will get different user group. The phase are different. And finally, when we transfer the message out about the blue one, I can make the blue one signal maybe is stronger, and the other signal we will be reduced maybe to become 0. And finally, all the terminals can get more resources. Of course, when we do the configuration, we no need to calculate the value of the Q, but we only to choose the Wave 2 technology is enough. To choose Wi-Fi 2, to choose Wi-Fi 5. Of course, when you buy the devices, you have to check the AP support the support Wi-Fi 5 or not, support Wave 2 or not. Otherwise, this function cannot be used. Like this one, we can change the phase to let some user to get the blue signal. And also we can change the phase to let the other signal to like this blue one, the signal to become 0. So about the wave 2, we can have multiple user and support MIMO technology. We can send out with this MIMO with this station at the same time. So we can make each station the throughput to become 260, but all of them can get the throughput at the same time. This is different with wave 1. About the wave 1, maybe finally we also can find the throughput is 300, maybe it's higher than here. But about the communication between AP and the station, in wave 1, we have to wait the station to transfer all, and then I will send out the message with AP together. This is wave 2. So the difference between wave 1 and wave 2, the technology of the modulation technology are same, 256 QAM. But the different one of wave 2 is we can use 160 bands and 8 plus 8 bonding technology. And about the special streams, with one, theoretically we can support 8 streams, but now at present we only can support 3. But how about the wave 2, we can support 8. And the MIMO technology, the wave 1 is a single user, but about wave 2, we can support multiple user. So about the RIP is a little different. Wave 2 can support up to 60.9 gigabit hertz, gigabit BPS. So this is wave 1 and wave 2. So when you buy the products, you also have to check these parameters. I think in the page on the office on Ruijie office website, you can see the detail. This product can support Wi-Fi 5 or not, and support wave 1 or wave 2. We can see the detailed information here. And the other protocol is Wi-Fi 6 protocol. About the Wi-Fi 6, the AO2AX, we also can improvement the rate and to make more subscribes. AO211AC, we can support 238. But about Wi-Fi 6, we have 908 data subscribe. So this is a data subscribe, but the totally subscribe about the Wi-Fi 6, we can support 1024. Of course, this needs a higher performance of your devices. Your devices can support AO211AX, then you can use multiple data subscribes. So this is the first one. So about this technology, maybe we can increase the speed enhance the speed to 4.7%. And another technology of the modulation technology is we use 1024 QAM. But about the Wi-Fi 5, we only use 256 QAM. So pay attention. AO211N, we use 64. This like the left one. We only can carry less information. About the Wi-Fi 5, we can carry more information on the places. And about the Wi-Fi 6, we even can create more information here and more than Wi-Fi 5. So in this technology, we can make the physical layer speed higher 25%. But pay attention, we also have some limitation. If in the same places you carry less words, you can see this A, B, C, D, E, F words very clear and very big, right? But if you make more characteristic on the places, we will reduce the text size to record more context. You will see the words will be smaller. And if you want to use higher QAM 1024 at a distance of 5 meters later, small characteristics are difficult to read. So this is a limitation. If you use a higher QAM, you cannot see the words clearly. So this is a limit. And another one for AO2 to 11AX, Wi-Fi 6, we use the technology of OFDMA. We can use multi-station. What's the meaning of multi-station? About the Wi-Fi 6, about Wi-Fi 5, let's say the process. If the TN, this car is a message we want to send to the destination, right? And each subscriber, we have to add the message, we have to add the data on the subscriber, and then the subscriber will help us to follow the traffic out. So in this process, you can think we use a car to help us carry the data information and send the message out. Then let's see the process of the Wi-Fi 5. We have lots of message have to send out, then send to the message one by one, right? And on this process, maybe on the first line, the blue one, we have 10 bits have to be sent out. We will use 100 cards to help us to forward out. But about the second message, maybe we're only 5 bits, but we still use 100 cards to help us forward the traffic. So in this process, maybe about the 10 bits, we only need 50 cards is enough. The rest 50, we also have to go with the first 50 cards together, but without any message. So this is a waste of the Wi-Fi 5. This is a Wi-Fi 5, surviving one cluster at a time. But about Wi-Fi 6, it's a little different. We will make different terminals and in different cars. Depends on the real requirement. And we will make the car as much as possible carry all the message at the same time. That's why we call it multi-station. Let's say this process. We can divide the car into multiple parts, and each part maybe provide the service for each source, for each station. So each station we will get the small part, but this part resources is enough for us. Although maybe about the station 1, I have to send out 12 bits, and about the 12 bits maybe we need 30 cards, and each part maybe we divide the card. Each part maybe is 20. So at least you need 2 part cards. They're totally 40 cards. You will waste 10 cards, but compare with Wi-Fi 5, 100, and you only need 40 cards. The waste is 60 cards. So this is a different. So we call about the Wi-Fi 6. We can provide the service for different terminals for different customers at the same time. This is the technology we call is OFDMA. This is an example for the 20 amperes channel. And another one for the multi-station MIMO, this is the real picture when we're working. Access, we have multiple antennas. And about the station, we also can support multiple antennas. And about the station 1, we will do the communication with first antennas. And station 2, we have 2 antennas with the communication of the second antenna with AP. And the station 3, we will use antennas communicate with AP third antennas. But about the Wi-Fi 5, you can think station 1 communicates with AP. Station 2 also communicates with AP. Station 3 also communicates with AP based on different time. But here we can divide the communication based on the antennas. And another one for the faster transfers the message. Wi-Fi 5, we will use the data transmission. The data frame are not distinguished. What means not distinguished? If the station needs to complete the de-encapsulation a message from the learning, that means, for example, now my AP sends the message to station 1. And the station 1 have to delete the physically, delete the destination MAC address. And then they will find that this message not sent to me. And finally, I will discover. And within this time, this is a waste because you have to stop here and to do the de-encapsulation and finally to discuss the message because this message not belong to you. So this is a limitation of the Wi-Fi 5. But about the Wi-Fi 6, we have one solution we call it BSS color. BSS color means when the transmission between the AP and the AC, between them transmission, I will direct it to send a different color to the station to know. For example, station now connect with the AP1, and AP1 will give the color for you for the blue. And now if AP2 sends a message to station 1 and the color is red, and the station will directly discuss the message because depends on the color. I will no longer to make the physical bit to become the digital 0101 and then continue to decapsulation the destination MAC address. I don't need. I will direct it to know this message I have to deal with or not based on the color. So I can get more time, more resources to deal with the message I have to deal with. So this is the BSS rapid recognition. And let's see the process. For example, now the station connect with AP1 and except AP1, there also may be the AP2. And they maybe AP1 and the AP2 have the same coverage with the station A. So station A can receive the message from AP1, also can receive the message with AP2, but maybe the station will not reply the message for AP2 because now I connect with AP1. But at this time, maybe AP2 sends a message. So the station also in the coverage of AP2 together. So the station have to receive it and synchronize and demodulation the message from the AP2 at first. And then to recognize the destination MAC address. And maybe this is a broadcast message. and then I will take the de-encapsulation again and find the destination IP address not belong to myself, and then I will discard it. In this process, on my side, maybe the time is very short, but for the computer side, this is a longer time because at this moment, maybe the correct message AP1 also sends the data out. Then, because now the station processing the data from AP2 and miss the data from AP1. So about Wi-Fi 5, the station synchronize and demodulation the interference signal first. So we were missing the correct signal. If we missing, we will let the AP1 to send the message again. That's why because of the missing, because of the conflict, because of lots of reasons, someone maybe will find the wireless signal, the wireless speed is lower than the wired speed. Because we have lots of resources, I have to receive lots of resources from the around, from the other AP, from the other stations, because we low in the same signal coverage. So this is the Wi-Fi 5. But about Wi-Fi 6, also the same scenario connect with two APs. The different one is AP2 also sends a message out, and the station will receive it. But this message carries a BSS color. You can think this is a color. And the station will immediately recognize this color not belong to AP1 because now I already connect with AP1. Then I will directly discard it. At this moment, AP1 sends a message to station, and the station already discussed the message from PC2, so I can synchronize, complete, and receive and demodulation the message from AP1. This is the advantage of the Wi-Fi 6. We can rapid recognition of the BSS color. So that's why we say on the Wi-Fi 6, the message also can deal with more correct information. But pay attention, although in Wi-Fi 6, you use this technology of BSS color, maybe also you will deal with some wrong message and miss the correct message. Also exists because in your around all the message you can receive, but you can decrease the possible to miss the correct message. So this is the BSS rapid recognition. And another one for the dynamic CCA threshold. About the AO211AC, we call one problem is maybe I deal with the incorrect message, so I will missing the correct message. Another one maybe is all the information, all the terminal, AP and the station were located in the same meeting. And in this process, what's the principle of the wireless? One, before we want to send out the message, I have to listening. If now the channel is idle, the resources is empty, I will send out the message. And when I send the message, and in this time, I listen the other voice, I get the other signal from the other maybe terminal from maybe the other APs. The signal is conflict. So everyone will stop to transfer it immediately in order to reduce the conflict. So this is a principle of the wireless transmission. And about the Wi-Fi 5 means all the devices located in the meeting. Like now I'm have training to you. We were in the big group. Now we totally have 65 people together. And if I'm talking now, everyone have to listening to me. If except me, one people is talking, we have to stop here and waiting a random time and send the message out. And about the Wi-Fi 6, we will divide the different people in the group. So we can divide a whole meeting in several smaller groups. And in this scenario, if one group there is a conflict, it doesn't matter. The other group still can forward the traffic with still can forward the message together. This is a very similar function like the VLAN. So we can design different CCA value for different group. So also can increase the speed of the network. So the key technology of Wi-Fi 6 is higher rate multi-station transmission technology and anti-interference. The last one is used to avoid the conflict as soon as possible. And the first one, the short GI, some QAM technology, some bonding technology, we want to make the rate higher. Because if the rate is higher, that means at a certain time you can send out more message. But pay attention, if this message is processing to be translated, maybe lost, maybe conflict, we have to let the sender to give us a new devices again. So this also is a waste to transfer the correct message because finally we want to check how long you receive all the correct message. So we also need some technology like the BSS color, like the dynamic CCA threshold technology to help us to reduce the interference in our network. So compare the AL211N, AC, and AX. We will find about AL211N, the rate is 600 Mbps. Of course, based on how many streams you can use. And the AL211 Wi-Fi 5 with 1.3 gigabit, with 2, 60.9 gigabit, and the AX is 9.6 gigabit technology. And what's the technologies we can use here? And what's the detailed technology is different between the 11N Wi-Fi 5 and Wi-Fi 6. Of course, if you want to use the Wi-Fi 6 technology, first you have to buy the devices support Wi-Fi 6. Although your terminal devices have to receive this technology. For example, the AP can support Wi-Fi, the BSS color. I will give different terminals, for example, the special color to indicate the AP. But your client cannot support this characteristic. That means this feature also cannot work. So this is the difference of AL2 to 11N, AC, and AX. So this part we talk about the detail of AL2 the 11N, AL2 11AX, and AC technology and different band of 2.4G, 4G, and maybe about 8G. About 2.4G, we have 14 channels we can use, and the non-interfering channels is 1611. And about the 5.8G has 13 non-interference channels can be used at the same time. That's why if you have 5G, maybe in your devices can support 5G. We suggest to use 5G because we can have lots of channel can use, and you can use some combined technologies together to make the speed upper. But pay attention, the coverage. Of course, and the signal pass through the wire and some body, some dots. The ability about the 5.8G is shorter ability than 2.4 gigabit. So depends on your real requirement. Besides this one, about 2.4 gigabit, we also have the other devices on your home maybe have the same band with the 2.4 gigabit, like the microwave, like the Bluetooth. So this also is the influence when you deploy the AP in your home. Okay, so this is the AL211 standard. And another one is, pay attention, If you want to use this technology like AO211AC or maybe AO211AX, the first one, you have to buy a device support this technology. The second one, you have to add some configuration to let the AP use this technology. So how to add the configuration to let the devices use this technology or not? Besides on your configuration,